Assalamu alaikum. Hello everyone. I hope you're doing great. Today we're gonna cover brushless DC motor. Understand the BLDC motor operation. So what you will learn in this project, you will learn what is a brushless DC motor or BLDC. Important components of BLDC motor, how brushless DC motor work, how to differentiate between outrunners and in-runners motors, important parameter of BLDC motor, and finally measure the thrust and speed produced by BLDC motor. A list of material we're going to work with today: a brushless DC motor, a jumper wires, 11.1 volt battery, electronic speed controller, or what's known as an ESC, a servo tester, a digital balance for measuring the weight and the thrust of the motor. So what is brushless DC motor? A motor converts supplied electrical energy into mechanical energy. There is various types of motors. Brushless DC motor, or what we call BLDC, is one of them. BLDC have high efficiency and excellent controllability, and they are widely used in many applications, like in drone, for example, drill equipment, and so many applications. In the BLDC, these coils in the BLDC are not located on the router. This is the router, the moving part here, but they are located on the stator. So this is the stator here. And brushes are not needed to pass the electric current into the stator. So that's why it's called brushless DC motor. This is the router here, and this is the stator. Important BLDC components. So let's look at this beautiful motor here. We have the shaft right here. The router, this is our router. This is the stator. Winding, and this is what produces the electromagnetic field. Here in that router inside, as we will see, there is permanent magnets, and finally this is the bearing where it gives a smooth rotation of the shaft, and we have the propeller. So let's look at inside what is inside this motor here. Let's look at this beautiful motor. In the bottom we have the stator with multiple coils and winding, which creates electromagnets, and on top the rotor has multiple permanent magnets. So how brushless DC motor work? So let's look at this diagram. In this diagram we have stator, which is made of 6 electromagnetic coils, and we have router, which is made of 4 poles or 4 permanent magnets. Once the coil is energized, an electric magnetic field is created, and actually the direction of the field can be determined by the right-hand rule of Fleming. You can determine which is south and which is north. And it's this electromagnetic field interaction with the permanent magnet, that's what causes the movement of the router. And each time a coil is energized, this push and pull movement between two magnetic fields keep this router moving and rotating. But as you see, only using one set of coils, it's not efficient enough. But what if we have some kind of device that actually trigger another set of coil to have a stronger torque? So that device is what we call an electric speed controller that use an IC circuit, MOSFETs, and some sensors to know exactly when to trigger the second set of coil to help with the speed and torque of the motor. So in runners versus outrunners BLDC motor. So what we have here, the rotating part of the rotor is inside, the coils are outside. This is the in-runner BLDC. And in this scenario, we have the rotating part outside. As you see, the permanent magnets are outside. The stator with coils are inside. This is an outer BLDC motor. And we're going to be, we used outer BLDC motor for the drone project. As I mentioned, the BLDC motor used in the drone, the project, it is an outer runner because the rotor is outside and the stator has all coils are inside. The motor controller on the right, which is called electronic speed controller, is connected to a power source in one side and to the motor on the other side. Thrust to weight ratio. In the drone project, it was very important to make sure that all selected motors can produce at least twice the thrust of the entire weight of the drone. If the thrust of all combined motors is low, the drone will not respond to our control. And if the thrust of all combined motors is high, the drone will have greater agility and acceleration, but it will be very hard to control. KV rating is nothing but the RPM or revolution per minute of the motor produced per volt. If we take, for example, 1000 kV motor and an 11.1 volt LiPo battery, the total RPM produced, it will be 1000 times 11.1 volts, which give us 11,100 RPM. So the higher the KV rating, the higher the RPM, the higher the voltage, the higher the RPM. But the RPM, as you know, if it's a windy situation, for example, the drone will not fly as fast because of that resistance of coming from the air. So what motor size should I use? Generally, the brushless DC motor is recognized or categorized by 4-digit number. For example, the motor we use in the project was named 2208. The first 2 digits basically represents the diameter of the stator. So if you have from this end to that end, you measure it, that's give you the 22 millimeter. And the second 2 digits represents the height of the stator, and that's 0.8 millimeter. That's basically how high is going to be your motor. So we have the diameter and the height of the stator. This is your stator motor. This is the winding, and here is the bearing. Essentially, the wider and taller the motor, the more torque that motor can produce. So what kind of motor size we should use? That depends on the actual frame size. So let's look at this table, relationship between the KV rating, the frame size, and the propeller size. So for example, my drone or the drone we use in the project was around 40 or 400 millimeter. So the choices of propeller you have from 8 to 10 inches. And the kV rating that is recommended should be 1000 kV or lower. So this is just a table that you can use basically and gauge you to pick the right motor size. How to wire BLDC motor with an ESC controller? So basically, the brushless ESC controller creates a three-phase AC power output from a DC power to run the motor by sending a sequence of AC signals generated from the ESC circuitry. So let's say we have our ESC here, controller. We have a power source, which is our 11.1 volt LiPo battery. From this, we have a DC current being converted to an AC current, and that's why we have three wires here, okay? And using at any one time, only two wires are being activated, okay? And this is how we run a DC motor. We're going to be using a servo tester in this project to control basically the speed and which phases we're using to run the motor.
This is the test setup for the 2208 brushless motor. What I have here, I have a 3D printed arm, servo tester, 11.1 volts with 5000 milliamp hour, and a digital scale. Let's turn it on and check the thrust. What is this motor can do here? I'm gonna start turning the throttle on, maximum speed. I do 600 grams. Oh, very strong, very strong, very strong. I'm gonna reduce the throttle now. Very strong. Good test.